Hi, in this video, I'll show the basics of graphs on the XY plane, a quick intro to scatterplots, and show how these math concepts are applied to the supply and demand curves in economics. This is an interactive lesson, so get yourself some paper or writable tablet and be ready to draw graphs. The basic concepts of graphing came from the 17th century philosopher and mathematician René Descartes. He's the same one who gave us "I think, therefore I am," that one. What he realized was that we can use axes to locate things in the world. Let's first take the number line. If we live in a one-dimensional world along that line, and we have those two dots, how do we tell people where they are located? Descartes' idea was to put in numbers along that line. Then we can tell people that those two dots are at -3 and 3. If the line is vertical, we can do the same thing, put in numbers. That would be a vertical number line. And traditionally, the numbers go from bottom to the top. Let's now move to a two-dimensional world. We have those two dots. How do we tell people where the dots are? If one number line is good for one dimension, then in two dimensions we'll use two number lines. We call them the axes. The horizontal is called the x-axis. The vertical is called the y-axis. And we make sure they cross each other at the point when they're both at 0. Once we do that and we put it in, we can say that in this case, the big red dot is at the spot where both axes are 0, and people can go there and find it. And the small blue dot is at the spot where if you look down the horizontal axis, it's at 3, and if you look sideways at the vertical axis, it's at 2. The number 3, 2 are the coordinates of the small blue dot, and we write the coordinates with parentheses. Let's now practice. Plot these points. 4, 2, -1, -5, 0, 6, 0.5, 0.5, and -5, 0. Press pause, find some paper, draw the axes, and plot these points. Come back when you're done. All right, here are the points. Now that we know how to plot points x, y, if we plot a whole bunch of points x, y that represent values that occur in some context, it's called a scatterplot. If you've seen research papers that have data, I'm pretty sure you've seen scatterplots. They look like these. Let's do an example. We asked a group of college students how many cups of coffee they drink per day and how many hours of sleep they get per night. One person may say, "I drink 2 cups and I sleep for 7.5 hours. We want to plot this piece of data on a graph. Here is the coordinate system with cups of coffee on the horizontal and hours of sleep on the vertical. See if you can plot this piece of data. 2 cups of coffee, 7.5 hours of sleep. Press pause and come back when you're done. You should get that dot right there. That dot corresponds to 2 cups of coffee on the horizontal axis and 7.5 hours of sleep on the vertical axis. We know which axis goes with cups of coffee and which axis goes with hours of sleep because the axes are labeled for us. And we know where 2 cups of coffee and 7.5 hours of sleep are on the axis because they have numbers on them. Here's a rule for drawing graphs. It is important to always label the axes and to scale them, meaning to put numbers on them. Back to our coffee drinking college students. Let's say we ask more people and we get all of these responses. Can you plot the data points on the graph? Press pause and come back when you're done. Welcome back. I hope you drew these dots. Congratulations, you just drew a scatter plot. What a scatter plot does and what it is useful for is it shows a pattern in the data. In this situation, if you go from left to right, it means people drink more coffee. And the scatter plot tells us that the dots fall from high to low, meaning people sleep less. That's the purpose of a scatter plot. Now let's apply it to economics. First, let's talk about the demand curve. The word demand in economics refers to the quantity of a good or service that people, the consumers, are willing to buy. Economists want to know if the price of something goes up, do people buy more or less of it? How would they figure it out? Well, they would go out and collect data and draw a scatter plot. Suppose we have these data points. They show us how many pairs of shoes people buy given the price of those shoes. Go ahead and plot these data points. Press pause and come back when you're done. Welcome back. This should be what you have. Before moving on, let me ask you another question. What happens if I give you the data this way? What happens if I list the table the other way around with the prices first? Go ahead and plot these dots on these axes. Press pause and come back when you're done. Welcome back. This was a trick question. If you look at the label on the axis, they have not changed. The table may have swapped the columns, but the axes on the graph are still the same. In economics, quantity is always the horizontal axis, price is always the vertical axis, regardless of how the data are shown in the table. The graph is still the same even though the prices are listed first. That's something you need to be aware of. In economics, quantity is the horizontal axis, but is often given second on the table. Price is the vertical axis, but is often given first. That is opposite of the way algebra classes are. In algebra, you're always given a table with x first and y second. This is important, so I'm going to stay on this slide for a little bit to make sure this sinks in, or for you to take notes. Okay, back to the demand table. If we connect the dots, we have a full graph, and it is called the demand curve. It shows the relationship between the price of a good or service and the quantity demanded by consumers. This one has what we call a downward slope or a negative slope. When a curve has a downward slope, the two variables move in opposite directions. If you go from bottom to top, you see that the dots go from right to left. Bottom to top means prices go higher, price increases. Right to left means quantity decreases. This curve says as price increases, the quantity demanded decreases. That's actually a rule in economics called the law of demand. All else being equal, as the price of a good or service increases, the quantity demanded decreases. Conversely, as the price decreases, the quantity demanded increases. If you're asked to draw a demand curve, always draw a curve like what you see right now, sloping down. All right, that's the demand. Let's now take a look at supply. If the price of shoes increases, do companies make more shoes or less shoes, more shoes or fewer shoes. Again, we collect data and we get this table. Go ahead and plot these points. Press pause and come back when you're done. Welcome back. This should be what you have. Don't forget, the quantity goes by a horizontal axis even though it comes second in the table, and the price goes by the vertical axis. You'll notice that the supply curve slopes up. It means as price increases from bottom to top, the dots move to the right, showing that quantity supplied also increases. Mathematically, when the curve slopes up, or a positive slope, the two variables increase or decrease together. That is the law of supply. All else being equal, as the price of a good or service increases, the quantity supplied increases. Conversely, as the price decreases, the quantity supplied decreases. Now let's put supply and demand in the same grid and let's practice getting information from the graphs. Answer these questions. What happens when price is $80? What's the difference between quantity demanded and quantity supplied at that price? Same question for when price is $40 and when price is $60. Press pause and come back when you're done. Welcome back. Let's take a look at $80. Here's the position where the price is $80. Check the quantity. The supply is 70,000 pairs of shoes. The demand is 50,000 pairs of shoes. Suppliers bring 70,000 to the market, but consumers are only willing to buy 50. There is a leftover of 20,000 pairs of shoes. That situation is called a surplus. When the price is too high, there's a surplus. That's the situation at $80. If you haven't done $40 and $60 yet, go ahead and press pause and do it now. If you have, let's move on. At $40, we're down here. On the demand curve, the quantity demanded is 90,000 pairs of shoes. On the supply curve, the quantity supplied is at 20,000 pairs of shoes. That means at this price, people want to buy 90,000 pairs of shoes, but suppliers only bring 20,000 to market. We're short by 70,000 pairs. In fact, that's what economists call it. They call it a shortage. When the price is too low, there's a shortage. Now, what happens at price of $60? $60 price level is here. At that level, both quantity demanded and quantity supplied are at the same spot. It means suppliers bring a certain quantity of shoes to the market, and that is also the same quantity that consumers are willing to buy. Suppliers get to sell all they're willing to sell, and consumers get to buy all they're willing to buy. That point is called the equilibrium. In this graph, the equilibrium price is at $60. All right, what we've done so far is to learn how to mathematically get information from the supply and demand curves given different price levels of the good we're looking at. This exercise actually illustrates this rule in economics. When the only thing that changes is the price of the good or service we're looking at, the supply and demand curves stay still. We look at different price levels, different points on the supply and demand curves, but the curves themselves don't move. Economists call it moving along the curves. Now, let's make some changes outside of the price of the good or service we're looking at. What if, for whatever reason, people don't feel like wearing shoes anymore? What if everyone wants to switch to boots? For example, if a bunch of celebrities start wearing boots instead of shoes. What happens to demand? demand decreases, because that's the assumption, right? That people don't feel like wearing shoes anymore. People buy less shoes, fewer shoes. There's a decrease in demand. This next question is important. There's a decrease in demand, but at which price? At which price does demand decrease? Do people buy less shoes at low prices, less shoes at high prices, less shoes at medium prices? The answer is at all price levels. Rich people, poor people, everyone moves away from shoes. What happens is called a demand curve shift. The whole demand curve decreases at all prices. In this example, let's say the decrease is by 30,000 pairs of shoes. At every price level, the demand decreases by 30. Go ahead and draw the new demand curve. Look carefully for which way to move when quantity decreases. Press pause and come back when you're done. Welcome back. I hope you figured this out. When a curve decreases in quantity, we shift it in the less quantity direction. And the less quantity direction is going horizontally to the left. Your answer should look like this. Because the quantity decreases at every price level, the whole demand curve shifted left. Let's practice getting some information out of these graphs. What's happening now at the old equilibrium price of $60? Press pause, think about it, and come back. The answer is, at $60, the new demand is lower than supply. There's more supply than demand, so there's a surplus. If $60 is no longer equilibrium price, what's the new equilibrium price now? Press pause and come back after you have the answer. Right here is the new equilibrium price. It's where the new demand intersects the supply. The price there is $50. And the quantity there is the equilibrium quantity. It's 40,000 pairs of shoes. Are we good? All right, here's the economics rule related to this. The supply and demand curves can shift when something other than the price of the good or service happens and it impacts supply and demand. When that happens, there may be a new equilibrium price level. We've just looked at a shift in demand. Let's now look at a shift in supply. Well, people want boots now, but suppose the shoe industry cannot switch to producing boots for whatever reason. But hey, thanks to AI, they can make shoes a lot easier, save a lot of money on human resources. The question is, for the same selling price, do they make more or less shoes? The answer is, at each price level, they make more shoes than before. They're saving money, so they can afford to make more shoes. The whole supply curve shifts to more quantity. Here's where we're currently at. Shift the supply curve to more quantity by 20,000 pairs throughout. Press pause and come back when you're done. Here we go. Here's the answer. The supply curve shifts to the right in the direction of more quantity. What is the new equilibrium price and quantity now? Press pause and do it. To find the new equilibrium, look at where the demand and supply curves intersect. The price there is $45. The new equilibrium price is $45. And the quantity there is 50. The new equilibrium quantity is 50,000 pairs. Are we good? Let's summarize. These are the rules for shifting curves. You have a decrease in quantity, you shift left. You have an increase in quantity, you shift right. Just remember that we shift according to quantity. I'm going to branch out of math and into econ a little bit and give you a list of a few things that shift the demand curve. Change in taste, change in population. For example, if lots of people move out to other countries or in from other countries. Change in income. For example, if there's an increase in minimum wage. Change in price of some other goods, substitute or complement goods. Those are concepts you'll learn in your econ class. Change in expectations about future conditions and prices. If something happens that causes people to think there may be a recession next year, it affects their spending today and changes demand, etc. This list is not exhaustive. Here's a list of a few things that shift the supply curve. Changes in production costs, the input prices, raw material, human resources, shipping. Weather events. In 2017, Hurricane Maria hit Puerto Rico, and it caused huge loss of supply of hospital equipment, IV bags and tubes. Definitely a shift in supply curve. Change in technology. If people find a new way to extract oil and gas, it affects the supply of oil and gas. Changes in government taxes, regulations, subsidies, etc. Just so you know, I can almost guarantee that every econ exam will include a question like this. Such and such thing happens, determine what happens to equilibrium price and quantity. You will have to figure out what happens to the supply curve. Does it stay still or does it shift? Which way does it shift? Same with the demand curve. And then find the point where the new curves intersect. Answer the question about the new equilibrium price and equilibrium quantity. All right? Summary of everything we've learned so far. Quantity is always the horizontal. Price is always the vertical, regardless of how the data are given. Like I said, this is opposite of how data tables are given in an algebra class. You need to watch out. If the question asks only about different prices of the good or service we're looking at, keep the supply and demand curve where they are. Don't shift them. Just look at the different price levels on the vertical axis. If non-price forces happen, shift the curves appropriately. More quantity, shift to the right. Less quantity, shift to the left. All right, hope that helps. Like, share, and subscribe for more contents. Any questions or comments, put it in the comment section below. And thanks for watching. Bye.